Imagine pointing one of the most powerful telescopes on Earth at what looks like an empty patch of space, expecting nothing but darkness, only to discover something monumental. That's exactly what astronomers did with the powerful Keck Telescope in Hawaii. They peered into the seemingly vacant abyss and found something extraordinary. Vast halos of gas surrounding galaxies, stretching out more than 100,000 light-years beyond their visible edges. Yeah, you heard that right, 100,000 light-years. To put that in perspective, that's nearly the distance between our Milky Way and the Andromeda Galaxy. So, what's the deal with these gas halos? Why are they so important? And how could this discovery revolutionize our understanding of how galaxies are formed and evolve? Buckle up, because we're about to take a journey deep into the cosmos and dive into the fascinating world of galactic gas halos, the cutting-edge tech that helped us find them, and why they matter way more than you might think. At first glance, a galaxy might seem like just a collection of stars, planets, and a bunch of dust swirling around a black hole. But that's just the tip of the cosmic iceberg. Surrounding every galaxy is something colossal, a shroud of gas known as a galactic halo. These halos are made up of hydrogen, helium, carbon, nitrogen, oxygen, basically, all the key ingredients that make up stars and planets. The kicker? They extend over 100,000 light-years from the galaxy itself, way beyond the stars we can actually see. Now here's where it gets wild. Recent research has shown that these halos contain a huge chunk of the universe's ordinary matter, or what scientists call baryonic matter, the stuff that makes up stars, planets, and, well, us. Some estimates suggest these halos hold a mind-boggling 70% to 90% of the universe's normal matter. So, if you thought the stars were the main event of the universe, think again. Most of the universe's material isn't glowing in the night sky. It's hiding in these massive, nearly invisible clouds of gas that surround galaxies like an unseen force field. Okay, so we've established that galactic halos are gigantic, but they're not just boring, static clouds of gas hanging out in space. These halos are dynamic and complex. Researchers used to think there was a gradual fade from a galaxy's edge into its halo, like a soft transition. Nope. Turns out, it's more like flipping a switch. There's a sharp, sudden boundary between the galaxy and its halo, suggesting the two regions are way more distinct than we once thought. But it's not just the sharp boundary that's intriguing. The gas within these halos isn't evenly spread out either. Some areas are denser, filled with different elements, while others are more like vast, empty voids. This patchiness likely reflects a chaotic history of galactic winds, gas inflows and outflows, an intergalactic dance that has been going on for billions of years. Galaxies aren't just sitting there quietly. They're constantly pulling in gas from these halos to fuel the birth of new stars. At the same time, massive events like supernovae can blast gas back into the halo, creating a sort of recycling system that's crucial for a galaxy's growth and evolution. You see, galactic halos aren't just bystanders in the grand scheme of the universe. They're active participants in the cosmic life cycle. When gas within a halo cools and condenses, it falls into the galaxy and forms stars. But it's not a one-way street. When something dramatic happens, like a star going supernova, that can send gas hurtling back into the halo. It's a give-and-take relationship that helps galaxies grow, evolve, and shape the universe as we know it. Now, here's where it gets even cooler. These halos glow, but not for the reasons you might think. Inside galaxies, stars radiate energy that lights up the surrounding gas. But out in the halos, there aren't enough stars to account for the glow. So, what's going on? One theory is that streams of gas are colliding with each other at high speeds, creating shock waves that generate just enough energy to make the gas shine faintly. Imagine massive rivers of gas crashing together in the void of space, lighting up like fireworks. Yeah, it's like that. Another possibility? Ultraviolet, UV light from stars or even black holes might escape into the halo, interacting with the gas and causing it to glow. However, we're still not entirely sure how much UV light gets out of galaxies, and whether it's enough to explain the faint glow we see in these halos. More research is needed, but one thing is clear: these halos are anything but boring. So, how does all this glowing, colliding, and recycling impact galaxy formation? Big time. These halos are crucial because they act as giant reservoirs of gas. Galaxies rely on this gas to form stars, planets, and everything else that makes a galaxy tick. Without these halos, galaxies would run out of gas and, well, stop making stars. It's kind of like how a car needs gas to keep running. The galaxy needs its halo to keep growing. What's really interesting is that these halos aren't heated uniformly. Inside galaxies, stars heat the gas with their radiation, but out in the circumgalactic medium, CGM, it's a different story. Here, gas is heated by more diffuse sources, possibly including energy from nearby galaxies or even intergalactic shocks. This uneven heating creates distinct boundaries between a galaxy's interstellar medium, ISM, and its CGM, helping us understand where a galaxy's influence fades and the larger cosmic web begins. Speaking of the cosmic web, these halos are also filled with elements like hydrogen and oxygen that extend far beyond a galaxy's visible edge. And they're not evenly distributed either. The farther you get from the galaxy, the less of these elements you find. This patchy distribution suggests ongoing processes that are constantly altering the chemical composition of these halos, raising all kinds of new questions about how galaxies interact with each other. Here's where things get really interesting for us Earthlings. The halo of our very own Milky Way galaxy stretches out about 100,000 light-years. And guess what? Andromeda's halo does the same. Given that the Milky Way and Andromeda are on a collision course, their halos are likely already overlapping. That's right, the cosmic forces of these two massive galaxies are starting to mingle in a slow-motion galactic dance that will eventually lead to a merger. This overlap of halos offers a unique opportunity to study how galaxies interact before they physically collide. By analyzing the region where the Milky Way and Andromeda's halos meet, astronomers hope to learn more about the cosmic processes that might lead to their eventual union. It's a little like watching the beginning of a grand cosmic romance unfold, except instead of flowers, it's gas clouds, and instead of love, it's gravity. Now, none of this would be possible without some seriously next-level technology. The discovery of these vast galactic halos was made possible by the Keck Cosmic Web Imager, a cutting-edge instrument that uses a new type of spectrograph to capture incredibly faint light from gas that's tens of thousands of times dimmer than the galaxies themselves. And where better to put this high-tech gadget than atop Mauna Kea, one of the tallest mountains in Hawaii, where the air is clear and light pollution is minimal? With this tech, astronomers like Nikki Neelam and her team have been able to peer deeper into space than ever before, capturing the first detailed image of a galactic halo. This breakthrough has opened up a whole new chapter in our understanding of the universe, giving us a fresh look at the unseen forces that shape galaxies. And there's more to come. The James Webb Space Telescope, set to revolutionize astronomy, will take things to the next level by exploring halos and other faint cosmic phenomena in the infrared spectrum. With its ability to detect temperature variations and chemical compositions within halos, Webb will provide even more insights into these mysterious structures that play such a vital role in the grand story of the universe. So, what's the takeaway from all this? Galactic gas halos aren't just a footnote in the story of the universe. They're major players. They contain most of the ordinary matter in the cosmos, act as giant reservoirs that fuel galaxy growth, and may even hold the key to understanding how galaxies interact, evolve, and, in some cases, collide. The discovery of these halos is just the beginning, and with cutting-edge technology like the Keck Cosmic Web Imager and the James Webb Space Telescope, we're on the verge of unlocking even more cosmic secrets. If this deep dive into the hidden reservoirs of the universe left you as amazed as it did me, don't forget to hit that like button. And if you're as curious about the universe as we are, go ahead and subscribe for more cosmic explorations. Keep your eyes on the stars, and we'll see you in the next video.